is also part of reflection. Polarization is a part of refraction and absorption combined. Okay, so atla different aspects untai kabatti, but basically when light interacts, a change in medium, it either gets reflected ante enti, propagating back into the same medium, ante coming back into the same medium, gets refracted, propagating into the next medium, or gets absorbed. That means energy is absorbed by the medium. Okay, so these are the things that may happen when light is trying to interact with matter. Reflection is back into the same medium, refraction is back into the next medium, and absorption is by the medium. Okay. Reflected waves follow the principle, principle that angle of incidence is equal to angle of reflection, that you all know. Okay. Now, the angle of incidence and angle of reflection are taken with respect to the normal. Okay. And reflection comes into picture only when there is a change in medium. Okay. Reflection comes into picture only when there is a change in the medium. If the light is propagating in the single medium, then there is no possibility of reflection or refraction. There is no possibility of reflection or refraction, but absorptions may take place. Absorption may take place in the same medium also. Okay. So, angle of incidence is equal to angle of reflection in the case of reflected waves. Now, in the case of refracted waves, we follow Snell's law. Okay. So when the light is propagating from one medium to another medium, consider that theta I is the incident angle from the first medium and theta R is the refraction angle in the second medium. But these are the angles made by the light ray with the normal. Okay. So both of these angles are the angles made by the incident light ray with the normal. Okay. So what does Snell's law say is nu1 sin theta 1 is equal to nu2 sin theta 2, or nu I sin theta I is equal to nu R sin theta R. What is nu1 and nu2 or nu I and nu R? These are refractive index values of the two media between which refraction is considered, or for which refraction is considered. Okay, if nu1 is the medium 1 and nu2 is the refractive index of medium 2, and theta 1 is the angle of incidence and theta 2 is the angle of refraction, then nu1 sin theta 1 is equal to nu2 sin theta 2, or nu I sin theta I is equal to nu R sin theta R is the relation that is satisfied by the light ray propagating from one medium to another medium. Okay, right. Now, in this case, already you might, you know something. Okay, so I want to ask you then. Okay, when the light propagates from rarer medium to denser medium, will it bend towards the medium or away from the medium?
Towards the medium.
Any?
Towards the normal.
Towards the normal. Okay. When the light ray is entering from rarer medium to denser medium, will it bend away from the normal or bend towards the normal?
Towards the normal.
Okay. When it enters from denser medium to rarer medium?
Away from the normal.
Yes or no? Right. Now my question is
Yes.
why? Can somebody explain me why?
So when the
Because the refractive index, when a light ray passes from rarer to denser, the refractive index increases and hence the light ray moves away from the normal in the denser medium.
Enduku.
Refractive index
Okay, it actually bends
increases.
towards the normal, Kani. Okay, enduku. Why?
Sir, speed in rarer increases.
Good. So what? Why?
So atoms in rarer medium not constant, whereas in denser medium.
ఇక్కడ ఓకే మీరు ఎక్స్ప్లెయిన్ చేస్తున్నది ఓకే డెన్సర్ మీడియం రేరర్ మీడియం అంటే ఓకే డెన్సిటీ ఎక్కువ ఉండడము అంటే ఫిజికల్ డెన్సిటీ కాదు అక్కడ ఓకే ఆప్టికల్ డెన్సిటీ అంటారు దాన్ని ఓకే కాబట్టి ఓకే మోర్ నెంబర్ ఆఫ్ ఆటమ్స్ అన్ని అవన్నీ చెప్పకూడదు ఓకే
Okay, sir.
వై అనేది తెలుసా ఓకే హౌ మెనీ ఆఫ్ యూ ఆర్ ఫ్రమ్ సిబిఎస్ఈ ఇన్ యువర్ క్లాస్ టుడే ఎంతమంది ఉన్నారు సిబిఎస్ఈ వాళ్ళు ఓకే 1 స్టూడెంట్ శ్రీచందన ఒక్కరేనా
Even me, sir.
6 member raised.
7.
ఓకే 7
7
ఓకే
members.
7 members ఓకే ఓకే ఇది స్క్రీన్ దీంట్లో ఉన్నాను కాబట్టి క్లారిటీ లేదు ఓకే 7 members ఉన్నారు రైట్ ఓకే గుడ్ ఓకే ఈ 7 members ఎవరైనా ఆన్సర్ చేయగలగాలి నేను ఈ 7 members ని ఎందుకు అడుగుతున్నానంటే లాంగ్ బ్యాక్ ఐ హ్యాడ్ టు టీచ్ వన్ ఆఫ్ మై కజిన్ సిస్టర్స్ అంటే లాంగ్ బిఫోర్ యూ వర్ బోర్న్ ఓకే అప్పుడు ఓకే తన బుక్లో చూసి ఎక్స్ప్లెనేషన్ చూశాను ఓకే ఇట్స్ గుడ్ కాబట్టి అది కంటిన్యూ అవుతుందో లేదో నాకు తెలియదు ఇప్పుడు సో I just wanted to know whether you people know it or not. Start.
Yeah, so like the speed of the at the interface of the two mediums, the speed of the atoms in the denser medium are slower than the speed of the atoms in the rarer medium. So that bending of the light rays takes place due to the difference in the speeds.
ఒక్క నిమిషం మా బాగానే ఉంది ఓకే బట్ వై షుడ్ ఇట్ చేంజ్ ఇట్స్ డైరెక్షన్ ఓకే స్లోవర్ అనేది ఆన్సర్ కరెక్ట్ ఉంది ఆన్సర్ కరెక్టే బట్ వై షుడ్ ఇట్ చేంజ్ ఇట్స్ డైరెక్షన్ ఓకే see I'm leaving the question okay I want you to think okay I want you to think okay sare parledu okay next coming okay what is refractive index what's the definition of refractive index okay is refractive index a number
Yes, sir.
Good. Is it an integer or a real value?
Real value.
Yes, sir. It's a,
Real
I
value.
think it was C by V, sir. Like, so it would be an
Real
integer
value.
value.
Okay, real value. So,
Yeah, actually.
okay, good. And can we have negative values for refractive index?
No, sir.
No, sir.
No?
No, sir.
Okay, good. Okay. Now looking at this expression, nu1 sin theta 1 is equal to nu2 sin theta 2. Okay, nu1 is equal to or nu I, okay, whatever you want to see. Okay, nu I is equal to nu r sin theta r by sin theta I. Can that not be negative? When can that be negative?
When any one of the refractive indexes is negative.
Yeah.
Sir, I don't think it would be negative, sir.
No,
Huh.
sir. Negative.
Because
Will it be negative or not?
yeah, C by V, C would be speed of light in vacuum. And I don't think it will be.
Okay. So I'm looking at this formula. Okay, you tell me from this formula now. I'll go back to that again. Okay.
In the case of total internal reflection,
Excellent. Okay.
Sir, it won't be negative, sir. For it should be negative. Sign should be above 180 degrees.
Okay.
So here ray can't be more than 180 degrees. So it
Okay.
should be positive.
Excellent argument. Excellent argument. Okay. Now somebody else was talking with regards to C by V. Refractive index is also defined mathematically as a ratio of velocity of light in vacuum to the velocity of light in that particular medium. Okay. Refractive index of any medium is a comparative value of velocity of light with respect to vacuum. Okay. So you are dividing velocity of light in vacuum to velocity of light in that particular medium. Now, what will be the least value of refractive index? 5 seconds. 5, 4, 3, 2, 1. What will be the least value of refractive index? With that particular definition, that is
Zero.
velocity. Yeah, ma?
0.
0.
1. 1 sir.
మనం ఇప్పుడే డిఫైన్ చేసాం కదా refractive index is velocity of refractive index of a medium is the ratio of velocity of light in vacuum to the velocity of light in that medium. Okay, 0 కావాలంటే న్యూమరేటర్ 0 కావాలి, లేకపోతే డినామినేటర్ ఇన్ఫినిటీ కావాలి. Okay, denominator has a limitation that velocity of light in any medium is less than or equal to c, less than or equal to c. And in the numerator also you have velocity of light in vacuum, which is equivalent to c. So the smallest value of refractive index is 1 and never less than 1. Okay, right. But this is something, okay, this is something which we are accepting even now. But there are, okay, as you said, okay, there are some experiments which are giving you different values. That means there are particles which are moving with velocities greater than c. There are particles which are moving with velocities greater than c. As I talked with regards to your muon particles in CERN experiment. Okay, the God particle గురించి మాట్లాడినప్పుడు ఇప్పుడు చెప్పాను. Okay, వాటి proof and వాటి explanations are still okay in the higher realm of physics. So నాకు కూడా తెలియదు. Okay, I just have to wait for them, right? Okay, what do you see here? Five seconds. 5, 4, 3, 2, 1. What do you see?
The car is able to move like easily in the first, in the second picture. In the first one, it's having some difficulty.
Right. So we are talking about the same car. Okay, with same power and everything. That means this is your light ray. Okay, when it is in okay the left hand side medium, then its velocity is less. That is in a denser medium like thing. And when it is in the okay black top rope, its velocity is more. Okay, that's how you should be looking at when the wave is propagating from one medium to another medium. Here the wave is your car. Wave is your car. Medium are the roads. So when you change the medium, the velocity of the car does change. Okay, right? That's how you should be understanding. Whenever the wave propagates from one medium to another medium, there will be a change in velocity. Okay, yeah, the same thing is explained here. Denser medium have lesser wave velocity, rarer medium have greater velocity, vacuum has highest velocity c. Story learning ఇంతకు ముందు already మీకు తెలిసినవే. Okay, the only picture that that's of important is this one, where car is your wave and the medium is nothing but your road. Okay, so velocity of the car changes when it is changes the medium. Okay. Okay, good చెప్పాలి. Right, okay. For example, if you are moving okay on the blacktop road, okay, and all of a sudden okay there comes a very big vehicle onto your right, so you'll be moving to the left. When you move to the left, you may okay come down from the blacktop road. Actually okay, now to all of you, okay, what do you do is at home do try to work out. Okay, మీ ఇంట్లో చిన్న కార్లు ఉంటాయి, బికాస్ ఆల్రెడీ మీరు కార్ డ్రైవింగ్ చేసిన ఎక్స్పీరియన్స్ లేకపోతే మై ఎక్స్పెరిమెంట్ గోస్ వేస్ట్. అందుకని ఈ చిన్న కార్లు ఓకే ఇంట్లో ప్లే కార్స్ ఉంటాయి కదా. ఓకే, టేక్ దోస్ కార్స్. ఓకే, ఒక దగ్గర ఒక శాండ్ వేయండి, కొద్దిగా శాండ్ వేయండి ఒక ప్లేస్ లో. ఓకే, అంతకుముందు ఓకే ఐ మీన్ యూ ప్లేక్ ఓకే యూ మేక్ ఐ మీన్ యూ to say on a flat surface, put some sand in one region. Take your car, okay, start at one end of the flat region and okay drive it, or okay I mean try to push it. Then what happens when one wheel gets into the sand? Okay, okay, only one wheel gets into the sand and one wheel is on the flat surface. Then what happens? Car turns. Okay, experiment chesi. If you understand something, tell me. That will actually help you to understand why the light bends when it travels from one medium to another medium. Okay, సరే, అర్థమైతే గుడ్, అర్థం కాకపోతే అడగండి. మీరు అర్థం కాకపోయి అడగకపోతే I will not explain further, because all of you know that it bends towards the normal when it is moving from rarer to denser, and when it is moving from denser to rarer it moves away from the normal. మీ అందరికీ తెలుసు. Okay, you answered it, but why అనేది, okay, I'm giving you this example in the picture and I'm giving you what do you say, a hypothetical experiment to be performed at home. మీరు చేస్తే మీకు అర్థమైతే గుడ్, అర్థం కాకపోతే అడగండి, మీరు అడగకపోతే I don't have any problem. Okay, let's get on. Okay, another point that we need to understand is what happens to the ray when it is getting reflected. Okay, now we have seen that when it is passing from one medium to another medium, it bends. When it is passing from one medium to another medium, it bends. Apart from that, when there is a change in medium, reflection also takes place. When there is a change in medium, reflection also takes place. Okay. Okay, cannot open it there. Okay, let me see. Okay. Okay, this is a wave pulse. What you see on your screen is a wave pulse. Okay, it's an open-ended one, so it's going out. But if it is getting from a harder boundary, see what's happening to the wave pulse. When it is getting hit from a harder boundary, it's undergoing a phase change. Okay, change in its phase. So whenever a wave gets reflected from a harder surface, that means denser surface, it experiences a phase difference of pi. Path difference ni lambda by 2 lo cheptamu, time difference ni t by 2 lo cheptamu, right? So the above one is a wave pulse that is propagating through open ends and it's just going on. But when it is getting reflected from a hard boundary, see what's happening. Ante the this dot that you have over here, okay, that is rigidly fixed. Because it is rigidly fixed, okay, it is getting reflected back. Ante there is a phase change of 180 degrees. Okay, or path difference, additional path difference of lambda by 2. There will be additional path difference of lambda by 2. Ante pike poyedi kindiki vastund, right? It is getting reflected back. Okay, that's how it is okay, undergoing a phase difference of pi or path difference of lambda by 2. Okay, this is a very important point that is to be understood. Now what happens when it is a soft boundary? See what's happening. Clear? Did you see what happened here? So when the wave is getting reflected from a rarer medium, it does not undergo any phase change. Reflection is taking place, but it does not undergo a phase change. This is a phenomena that should be understood very clearly by the students. Okay, waves gurinchi anukunnappudu these are the three things. Okay, when it is getting reflected from a denser medium, it is undergoing a phase difference of okay 180 degrees or path difference of lambda by 2. Okay, but when it is reflected from a rarer medium, from a softer medium or rarer medium, it does not undergo a path difference or phase difference. Okay, right? Now, that's what is the case here. Okay, the incident wave goes and hits and undergoes a phase difference and comes out. Okay, this is what is reflection from a denser medium. Whenever a light ray is getting reflected from a denser medium, it undergoes a phase difference of pi or path difference of lambda by 2. Okay. Okay, next point of concern over here is optical equivalent path. Okay, sorry, optical equivalent path. Okay, Amma 31, you are the CR kada?
No, sir, it's Joshita, sir.
Acha, sorry, 56, huh?